Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about chemical bonding chapter. In this session we are going to say about different kinds of covalent bonds like multiple bonds and polar non-polar covalent bonds we are going to see now. Okay. First let us see about multiple bond formation, multiple covalent bonds formation. The covalent bond formed by the sharing of more than one pair of electrons between two atoms is called a multiple bond. Generally, we told about covalent bond as the chemical bond formed between two atoms by mutual sharing of a pair of electrons is called covalent bond, which is also called as single covalent bond or single bond. If two atoms they share more than one pair of electrons, like two pairs of electrons or three pairs of electrons, then the bond formed between them is called multiple bond. Okay. So if the covalent bond is formed by sharing of two pairs of electrons between two atoms, then it is called a double bond. See here they shown. So in this atom contributing two electrons, you can identify with the color, and this atom is contributing two electrons for sharing. Totally four electrons are shared between these two atoms. Nothing but two pairs of electrons are shared, and hence two covalent bonds are formed between these two atoms because of sharing of two pairs of electrons. So these two covalent bonds together called a double bond. Now we can say these two atoms connected with a double bond, which we call simply as multiple bond. Okay, the covalent bond formed by sharing of more than one pair of electrons between two atoms is called a multiple bond. If two atoms share two pairs of electrons between them, then the bond formed is called a double bond, double covalent bond. Okay, let us see an example. Formation of oxygen molecule. Each oxygen atom contributes two electrons and two pairs of electrons are then shared equally. If you see here this. So we know in the oxygen there are six valence electrons. Now in the formation of oxygen molecule, each oxygen atom shares two electrons or contributes two electrons for the bond formation, and hence two oxygen atoms share two pairs of electrons, and hence each oxygen atom will get octet configuration. If you observe this oxygen now, already there are six valence electrons, it is shared two more electrons with the other atom. Now totally 8 electrons it is getting, and hence it is getting octet configuration. In the similar way, if you see this oxygen atom also, it also attained octet configuration. By this they are forming a double covalent bond by sharing two pairs of electrons equally. Okay, this also can be represented like this: O double bond O. Two lines between the two oxygen atoms symbols represents a double bond between these two oxygen atoms. Okay, next let us see triple bond. If the covalent bond is formed by the sharing of three pairs of electrons between two atoms, then it is called a triple bond. Okay. For example, if you say formation of nitrogen molecule. In the nitrogen molecule, each nitrogen atom has five valence electrons. When these two nitrogen atoms approach each other, each nitrogen atom contributes three electrons for sharing, and hence three pairs of electrons are shared between two nitrogen atoms. See here, so that each nitrogen atom will get octet configuration. For each oxygen already nitrogen, there are five electrons already in the valence shell. By sharing three more electrons, it will get octet configuration. By this, between these two nitrogen atoms, three covalent bonds are formed, but they cannot be said separately three covalent. Altogether, they are said to be a triple bond. Nitrogen molecule has a triple bond between the two nitrogen atoms. This is formed by sharing of three pairs of electrons mutually between them. So this molecule, nitrogen molecule, also can be represented like this. Three lines between two nitrogen atom symbols represents a triple bond between the nitrogen atoms. Okay, that's about multiple bonds. Multiple bonds means what we said, the covalent bonds which are formed by the sharing of more than one pair of electrons between them are called multiple bonds. So double bond and triple bond will come under multiple bonds. We should know one thing here. Any two elements can share a maximum of three pairs of electrons. No two atoms can share more than three pairs of electrons between those two. Okay, maximum of three pairs of electrons can be shared between any two atoms. So maximum any two atoms can form a triple bond. Quadruple bond is not existing. So any two atoms can form either single or double or triple bond. No two atoms can share more than three pairs of electrons between them. Maximum they can share three pairs of electrons. That's why we discussed only about single bonds, double bonds, and triple covalent bonds between the two atoms. This is in between two atoms only we are telling. An atom can form more than four bonds also. Four covalent bonds also, or more than four covalent bonds also, an atom can form with different atoms. With the same atom, it can form maximum of three covalent bonds only. Only it can share only three pairs of electrons only with one atom. Remember that. Now let us see about bond pairs and lone pairs of electrons. Have a look at this Lewis dot structure of oxygen molecule. See this oxygen molecule here. Two oxygen atoms are having mutually, each one is having 6 valence electrons. See, they are shown with the dots and crosses around the oxygen symbol. And in becoming stable, when these two atoms approach each other, they share two pairs of electrons between them, isn't it? By that, each oxygen atom will get octet configuration. Now, these pair of electrons which are participating in the bond formation are called bond pairs of electrons. And on the other oxygen atom, there are still four more electrons which are not participating in the bond formation. You can observe. So this is one pair. They are numbered. So one pair, the two electrons together is called a pair. So one pair, two pairs, three, four, five, six. They have numbered here. Okay, observe these pairs of electrons ones. Out of these, the electron pairs 5 and 6 are involved in the bond formation, and hence they are called bond pair of electrons. See here, these two pair of electrons are participating in the one covalent bond formation. So the pair of electrons which are participating in the bond formation are called bond paired electrons or bond pair of electrons. Now we can say this is one bond pair and this is also one bond pair. 5 and 6 pairs of electrons representing bond pairs of electrons. The remaining, if you see, first, second, third and fourth pairs of electrons, these are present in the valence shell, but they are not involved in the chemical bond formation, isn't it? So these type of pair of electrons which are there in the valence shell of that atom and not participating in the bond formation are called lone pair of electrons. Okay, the pair of electrons which are participating in the bond formation are called bond pair electrons, and the pair of electrons which are present in the valence shell of that atom are called, and which are not participating in the bond formation are called lone pair of electrons. Now, certain molecules. So till now we have seen atoms, they participate in the bond formation to attain octet configuration. Octet configuration means getting 8 electrons in the valence shell. Generally, all the atoms after the bond formation, they attain this octet configuration or duplet if it is having one shell. We discussed it. But certain molecules, they do not follow this octet rule. Sometimes some atoms they get more than 8 electrons after the bond formation. And some atoms they get less, even after bond formation also they remain with less electrons than octet after bond formation also. These conditions we call as violation of octet rule. So in some molecules, atoms attain either more or less electrons than the octet after bond formation. Let us see some examples here. For example, consider the formation of PCl5 molecule. This is PCl5. Phosphorus atom has 5 valence electrons because its atomic number is 15. If we write its configuration, we get it as 2, 8, 5. So in the valence shell, phosphorus has 5 electrons. But here, this phosphorus shares its 5 electrons with single electrons of 5 chlorine atoms, and hence phosphorus atom shares 5 pairs of electrons, one with each chlorine atom, and forms 5 covalent bonds. Thus, phosphorus has 10 electrons in its valence shell in the PCl5 molecule, isn't it? If you see, already phosphorus has 5 electrons, and it is sharing one pair of electrons each with one chlorine atom. By that, finally chlorine is getting 10 electrons in its valence shell. But we know atoms, they will attain 8 electrons after the bond formation in their valence shell. That we say as octet. But here phosphorus getting 10 electrons in the valence shell. So more than 8 electrons it is getting. This is called superoctet, getting more than 8 electrons in the valence shell after the bond formations by an atom is called superoctet. Now you say PCl5 molecule is a superoctet molecule. It violated here octet rule. It is getting more than octet after bond formation. Okay, this is called superoctet. Okay, next here some more examples for the molecules having superoctet are mentioned here on the central atom. If you see SF6, in SF6 sulfur atom has 6 valence electrons because its atomic number is 16. Configuration, if it is written 2, 8, 6, in the last shell it is having 6 electrons. After bond formation with the 6 fluorine atoms, it shares 6 pairs of electrons, one each with one fluorine atom. By that, already 6 electrons are there. It is sharing 6 more electrons from fluorine atoms, one from each fluorine. By that, sulfur gets 12 electrons in its valence shell after the bond formation in the SF6 molecule. Thus, it is also called violation of octet rule. We know xenon is already having 8 electrons in the valence shell. It is sharing 2 pairs of electrons, one with each one fluorine atom, and hence it is getting 10 electrons in the valence shell. So it is octet rule violation. It gets 12 electrons. It is getting 14 electrons iodine because iodine is having 7 valence electrons already. It is sharing 7 pairs of electrons with fluorine atoms, one each with one fluorine. Thus, it is getting 14 electrons in its valence shell. It is called superoctet. Getting more than octet after bond formation is called superoctet. Okay, in the quite opposite to this. Similarly, consider the formation of another molecule BeCl2, which we call as beryllium chloride. In this, beryllium has 2 valence electrons because we know its electron atomic number is 4 and its configuration is 2, 2. In the valence shell, it is having only 2 electrons. So beryllium shares 2 pairs of electrons with one each with one chlorine atom and forms 2 covalent bonds. Thus, beryllium has only 4 electrons in its valence shell in the BeCl2 molecule. Isn't it? See, observe here, beryllium initially it is having 2 electrons and it is sharing one pair of electrons with one each chlorine atom. By that, beryllium is getting only 4 electrons even after the bond formation also in the BeCl2 molecule. So it is having still less number of electrons than octet. This is called deficiency of octet. Beryllium chloride molecule is deficient molecule, deficient of octet. We say beryllium molecule is a deficient of octet, means the central atom is still having less number of electrons than the octet even after the bond formation also. Okay, these are called violations of octet rules. Let us see some more examples in which the central atom is having still deficiency of octet, means less number of electrons than 8 even after bond formation. If you see boron trifluoride, BF3 molecule it is called. In this, central atom is boron and its configuration, if you say 2, 3, means in the valence shell it is having only 3 electrons and it is sharing uh, three pairs of electrons, one each with one fluorine atom. By that, it will get 6 electrons in the valence shell in the BF3 molecule after bond formations. Only 6 it is getting after the bond formation also. It is less than octet. That's why it is called octet deficient molecule. In the same way, aluminum chloride also. Okay, that's about violation of octet rules. Having more than 8 electrons is called superoctet. Having less than 8 electrons even after bond formation is called octet deficiency. Okay, now let us see. Oh, it has come here. Let us see about once again about these bond pairs and lone pairs. Bond pair of electrons. The shared pair of electrons which result in the formation of bond is called the bond pair of electrons. See, already have seen. Let us see once again here. Between the in the water molecule, if you observe, hydrogen and oxygen both are sharing a pair of electrons, isn't it? This share pair of electrons which are participating in the bond formation is called bond pair of electrons. And the lone pair of electrons means the pair of electrons present in the valence shell but not involved in the bonding is called lone pair of electrons or non-bonded pair of electrons. If you see here on the oxygen atom, there are two pairs of electrons which are participating in the bond formation. They are called bond pair of electrons. And if you observe still, there are two pair of electrons on the oxygen in the valence shell which are not participating in the bond formation. These are called lone pair of electrons or non-bonded pair of electrons. Okay, now let us see one more concept, that is polar and non-polar covalent bonds. Have you ever watched children playing together with a toy? Mutually they'll be sharing those. Sometimes they equally share the toys, and other times one child will take the other child's toy away. They'll pull the toys, isn't it? Have you observed this? Mostly we have observed those. You might have observed those. Sometimes children will be playing with the toys by sharing them mutually, and sometimes they pull them. One of the child will take those toys from the other child. Some types of chemical bonding are very similar to the way that children play with toys. This type of situation happens even in between the atoms also in the chemical bondings. Let us see what are those. First, let us see non-polar covalent bond. The covalent bond formed between two similar atoms or the atoms with the same electronegativity is known as non-polar covalent bond. So if two similar atoms are the atoms which are having same electronegativity, if they share a pair of electrons, then the bond formed between those two atoms is called non-polar covalent bond. Let us see an example. It is also defined as the covalent bond in which bonded pair of electrons is equally shared between two atoms is known as non-polar covalent bond. Actually here polar means charge formation, polarity it is actually. And if two atoms are having same electronegativity or same tendency to pull the electrons after sharing, both will mutually contribute one electron for the bond formation, and after the bond formation they share this pair of electrons equally because both the atoms are having same electronegativity. That means tendency to pull the pair of electrons towards it. Both have equal power. Then if this is pulling the pair of electrons towards it in this direction, and this atom will pull the pair of electrons towards it in this direction, both are having equal force, equal tendency, that is equal electronegativity. Then in which side this pair of electrons will move? They won't move in any direction. They'll be remained exactly at the center of these two atoms. So these pair of electrons are shared between these two atoms with equal force. Equally they are shared. Thus, the bond formed between them with equal sharing of electron pair is called non-polar covalent bond. Okay. So there is no formation of any charges. Non-polarity means no formation of charges. Pair of electrons are shared between the atoms equally. Let us see one example for this. For example, in the homoatomic molecule, homoatomic means same kind of atoms, if they combine, then the molecule formed is called homoatomic molecule. Like hydrogen, H2 molecule, O2, Cl2, N2, F2, etc. If you observe, same kind of atoms are there in these molecules. These are called homoatomic molecules. If both are of the same kind of atoms, then they will be having same electronegativity. So the shared pair of electrons will be pulled by the both the atoms with equal force in the opposite directions, and hence they will be shared equally. The shared pair of electrons is equally attracted by the two atoms. If you see the formation of covalent bond between two hydrogen atoms, just now we have seen already. Let us see once. So both the hydrogen atoms contribute one electron for the formation of covalent bond. Now, both are of same kind of atoms and both have same electronegativity. Both will pull the pair of electrons towards them with equal force. As they are pulling in the opposite directions with equal force, this pair of electrons will be exactly at the middle of two hydrogen atoms. They are shared equally with both atoms. Then there is a movement of electrons towards one atom. Thus, this bond is called non-polar covalent bond. Okay. Now let us see other kind. Polar covalent bonds. The covalent bond formed between two dissimilar atoms or atoms with different electronegativities is known as polar covalent bond. Means if the covalent bond is formed between two different atoms with different electronegativities, then the bond formed is called polar covalent bond. It is also defined as the covalent bond in which bonded pair of electrons is unequally shared between two atoms is called polar covalent bond. See here, two atoms contributing one electron from each for the formation of covalent bond, and this pair of electrons are shared between two atoms. But here, one atom is more stronger in the sense more electronegative than the other element. What happens? Pulling tendency will be greater for this atom. This will be having less tendency to pull the electrons. Now, this as it is having greater electronegativity, this will pull the electron pairs towards it. Of course, it won't take completely, but having more electronegativity, it will pull the pair of electrons towards it. By pulling like this, one extra new electron from this atom it is coming towards it, isn't it? By that, slightly it will get some negative charge, but it is not completely taking, it is moving towards this atom, and hence we say slight electronegative charge it will get, slight negative charge, that is shown like this, minus delta it is called. At the same time, if you see this atom slowly losing its electron towards other atom, by losing electrons we know atoms will get positive charge, but this atom is not completely losing, just losing towards the other atom, then it will get a slight positive charge, that is shown like this. So in this way, even though they are sharing a pair of electrons, but the sharing is not done equally. Unequal sharing of electron pair is happening. By that, both the atoms they will attain slightly opposite charges. This formation of charges is called polarity formation. Polarity means charge. Polarity formation means charge creation because of the pulling of electron pair towards one atom. So as charges are formed between these two atoms, this bond, this covalent bond is called polar covalent bond. Okay, the covalent bond in which electron pair is not equally shared between two atoms is called polar covalent bond. Let us see an example. For example, in the heteroatomic molecules, heteroatomic means hetero represents different. The molecules which are containing different atoms shared electron pairs between them are called heteroatomic molecules. If different atoms means they will be having different electronegativities. Even though they share a pair of electrons, out of those two atoms, one with a greater electronegativity, it will pull the pair of electrons towards it, and hence the polarity will be formed. Thus, the molecules are called polar covalent molecules. So let us see one of the examples here. Hydrogen chloride is mentioned. If you see hydrogen and chlorine, both will contribute one electron for sharing, each one electron. And hence, A pair of electrons are shared between chlorine and hydrogen. But here we know chlorine is a more electronegative atom. It can pull the pair of electrons very strongly towards it when compared to hydrogen. Hydrogen is less electronegative than chlorine. What happens? The shared pair of electrons are pulled towards chlorine strongly by chlorine towards it. Thus, as it is getting one more extra new electron towards it, it will get slightly negative charge. At the same time, hydrogen gets slightly positive charge on it as it is losing its electron towards chlorine. Thus, polarity is created. Thus, this bond formed between these two atoms in which electron pair is unequally shared is called polar covalent bond. Okay, the resultant bond is called polar covalent bond. Okay, this is about polar and non-polar covalent bonds. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates on recorded previous videos.